coming out today. Today we're going to be talking about building microservices on AWS. Since I always appreciate kind of knowing how current the content is, I just want to let you know that I updated it about a month ago here back in January. I have this presentation scheduled for about 60 minutes. There's a lot of content to get through. But each time I've given it, I've gotten a little bit shorter, so we should be able to kind of get through this in probably about 40, 45 minutes. Kind of break it down, kind of the format here. The first few minutes I'm going to tell you a little bit about myself, a little bit about my company. Then we're going to kind of talk about kind of how we traditionally do application architecture on AWS today. And then we're going to kind of talk about what the future looks like. So, greenfield application development on AWS has a lot of promise if we kind of build it around this microservices architecture. I'm going to talk a little bit about some of the ways that we actually do that. Since I have a lot of content here, I actually have 2 defined breakpoints throughout the presentation. And if you wouldn't mind, if you could just kind of please hold your questions until then. For those that are actually participating via Twitter, feel free to chime in whenever, and we'll actually kind of stop and read your questions when appropriate. So a bit about myself. My name is Jamie Began. I'm the founder and CTO of RightBrain Networks. I've been using EC2 for a while, actually since the beta back in 2006. I'm the founder and host of AWS Michigan, which is the Meetup group here. I currently hold all 5 AWS certifications, and this is my day-to-day. I mean, I'm very technically hands-on, and this is stuff that really interests me, and I appreciate kind of sharing it with kind of the larger audience out there. So RightBrain Networks is actually an AWS advanced consulting partner. Basically what we do is we consult with organizations of all sizes on kind of how to get started in cloud and how to get better in cloud, and kind of how to do cloud native application development on public cloud as well. We were one of the very first 6 audited MSP partners back in almost a year ago. So we've been, we're pretty small, but we've been able to do some pretty interesting things actually in the kind of the world of public cloud on AWS. So I mentioned we're pretty small. 100% of us here are based in Ann Arbor, Michigan, though we do travel pretty extensively around the country. We do business as I mentioned, with companies of all sizes, both kind of smaller startups and kind of larger, more established companies that are kind of looking to improve the way that they're building software. So let's rewind quite a bit here, and I'm going to kind of explain kind of what the state is today without kind of public cloud, how things look. So this is actual Google Analytics data from a customer of ours, and I kind of picked this one because it kind of shows a perfect workload example for public cloud. You've got these very, very spiky periods and these very peak and valleys going on here. So this is what it might look like in the traditional data center environment. We might have 4 servers or 4 racks of servers. Whatever it is, it's a pretty consistent supply. We're paying for the same floor space, same heating or same cooling, same power, everything, regardless of how much actual load we have on that particular application. So, what that kind of equates to here is kind of a lot of wasted money during when we're not actually using that equipment. But more importantly, is if we actually have a failure, perhaps right between a critical point in time. So now what happens is we've got a down server, storage array, something along that lines. So it's resulting in a very poor user experience. It might be HTTP 500 errors, it might be user timeouts, or worse, we're unable to accept orders. And that's going to last until we can actually get a replacement part in there and actually provision it and get it operational. So cloud kind of takes a different approach here. Or we might start off with the same equivalent amount of equipment. It's going to actually automatically scale depending on what our needs are. It'll actually kind of go down during our slow periods, whether it be evening or weekends or even a period of time of year. Automatically adjust as load demands. But even more cool is that it's a lot more resilient to failure. For example, if I were on a server, an EC2 instance at AWS, and I lost the server or lost a storage node, something along those lines, if my application is designed appropriately, it'll actually recognize that and kind of spin up a replacement. Generally within a few minutes, so I don't have to wait around and requisition hardware or panic in the middle of the night. I call autoscaling the heart and soul of EC2. There's a lot of people that are using EC2 just like they would a traditional virtual machine by just kind of installing everything on there and kind of treating it as a unique snowflake, just as you would a physical server. You can certainly use EC2 like that, but it's definitely not the best way to use it. You really want to bake in kind of the self-healing nature, and that's done with autoscaling. So, I keep mentioning kind of a self-healing application. Let's kind of break that down a little bit, and I'll explain exactly what I mean by self-healing application. At the foundational level, you need these autoscaling groups to kind of automatically create and replace instances on demand and according to the health of the underlying infrastructure. But in front of that, we need an elastic load balancer to basically take those incoming requests and distribute them on the back-end servers within that autoscaling group. We also have a concept of multiple availability zones. And this one's a pretty tricky one for people that are kind of new to AWS. It's kind of the difference between a region and an availability zone. So here's an example. I thought this was a pretty interesting find. This is actually a map of central Ohio. Generally, Amazon's pretty tight-lipped about kind of the actual configuration of their data centers, but this was actually published in the Columbus Dispatch, which is the local newspaper there. And what we actually see is a central region that actually is going to be brought online, and it's composed of 3 different availability zones, which are denoted by the different dots. And an availability zone is a data center or a small cluster of data centers, and then they're interconnected to other availability zones within the same region via private high-speed fiber. So there's generally only about a 2 millisecond latency between these different availability zones, but they're far enough whereas, for example, a tornado isn't going to take out all 3 of them. So that's kind of the primary difference between a region, which is a group of availability zones, and an availability zone, which is either a single data center or very closely connected data centers. In CloudWatch, if you've ever done any work with AWS, you tend to understand what CloudWatch is. It's a monitoring and metrics system. However, I can kind of consider it kind of the unsung hero of AWS. It goes vastly, vastly underutilized. More so than they just kind of report on the overall health of your resources, it allows you to kind of orchestrate kind of reactions to your environment when something happens. For example, I might define using CloudWatch. Perhaps I'm a trending topic on Twitter, which I'll actually show a little bit later on here. I can actually react. My application can actually grow depending on my Twitter activity is, or from a trending topic on CNN or something along that lines. Or working in even kind of more mundane business level metrics. I can scale on kind of the latency between when a user enters their password and presses the login button, how long that takes to respond. I can scale on that or do any other type of activity, and that's all coordinated via CloudWatch. It's a very, very powerful part of AWS's product portfolio. So, as we've got these instances or these servers kind of constantly scaling up and down, we obviously need a way to do that kind of automatically to provision them. When a new machine comes online, we obviously can't have an army of engineers, furiously typing at the console, configuring everything online. So we need a way to kind of programmatically do that. And that's done with either a server orchestration or a configuration tool. Now, there's a few options that you have. AWS obviously provides some kind of out-of-the-box solutions. Most notably, you got OpsWorks and Elastic Beanstalk. OpsWorks is basically managed Chef. Elastic Beanstalk is kind of a different design philosophy. It's a PaaS platform. It's designed to make deployments as easy as possible for kind of the more developer-focused people. I tend to call it AWS and training wheels because it kind of abstracts a lot of the autoscaling and load balancing and other types of more complicated concepts away and just allows you to simply deploy your code in the cloud. CloudFormation is quite a bit different than, in fact, I hesitated at all to actually put it as an orchestration tool, because it's really not. It's more about kind of deploying and designing kind of an overall infrastructure or architecture deployment. For example, I'd use CloudFormation to define my load balancers, my routing, my security groups, and then once I actually deploy that onto AWS, then generally when the servers come online, it's a different type of tool, say a Chef or a Puppet, that it's actually working within there. But in a pinch, you can actually abuse CloudFormation as an orchestration tool, so I kind of opted to put it in there. So standalone, I already mentioned a couple of them. If you're currently on-prem or in a data center using a Puppet or Chef, a SaltStack, Ansible, kind of pick your poison. You can certainly continue to use that in your AWS environment as well. And in a pinch, you can actually take an existing EC2 instance and snapshot that and create an auto-scaling group based upon that configuration. It's very simple to do. The downside is it's difficult to manage because every minor little change you make to that environment, whether it be a bit of code on there or username or password, you've basically got to reburn that image and redeploy it. It's not a very scalable way to do it, but if you want to get an auto-scaling application online in a hurry, that's certainly a way to do it. So Route 53, there are other highly available DNS. You can have the most resilient application on the planet online in the cloud, but if people don't have the ability to reach it, then it's all for naught. So you want to make sure that you're using a highly scalable DNS provider. It could be Route 53, or there's a number of providers out here. I specifically put this in here because I don't advise people kind of hosting their own DNS internally at their data center or on-prem, or using kind of your typical consumer shared hosting DNS. You want to use something that's quite a bit more robust. So let's kind of visually represent what this looks like. We're taking one particular region here. This is US East 1. And we've actually got two availability zones here. We've got US East 1A and 1C. And kind of we're going to define a single auto-scaling group that spans two availability zones here. And of course, in front of that, we're going to have a load balancer. Physically, this is a bit different, but conceptually, an ELB actually spans AZ, so we'll just kind of go with that to kind of simplify the illustrative purposes here. And it's pretty simple. It just takes incoming requests and kind of just round robin some amongst the different servers in the auto-scaling group. Of course, we kind of need to be storing data for this application to be somewhat useful. So in this case, our persistent data store is RDS. It could be Postgres or SQL Server or whatever engine you want on RDS. In fact, it doesn't even have to be RDS itself. It could be S3. It could be block storage. But in this case, we're using RDS. And we're using the HA configuration of RDS, which is basically an active and a passive node. So we've got an active node in one AZ that's kind of doing synchronous replication over to the standby database in the other AZ. And then we have all the read writes occurring to the master, and again getting replicated over to the standby database. This is a pretty simple, I'd call it a 2.5 tier application on AWS. It's our load balancer, and then our combination application web tier, and then our persistent data tier. So let's say we actually get a scale up event. Suddenly we're the hot topic on Twitter or Facebook, and our traffic's blowing up. So we get a rush of data to the ELB. And that basically kicks off some various rules that we have set up. Perhaps we know that our application's CPU bound, so we might actually scale on if the aggregate CPU utilization across our auto-scaling group is above 90% for 5 minutes, as an example metric. It knows to bring additional servers online, kind of provisions them, and then basically plugs themselves in a load balancer, and then they connect back to the database, and suddenly we've doubled our compute capacity. More importantly, though, let's say that in the heat of all this, we have some sort of hardware failure at AWS, which we didn't predict. Not a problem. It automatically detects that we actually have a failure here, does a little bit of kind of internal DNS trickery, and kind of sends everybody over to the standby node. This is actually a pretty cool feature of RDS. I don't know whether you've ever set up kind of replication in the database world, MySQL, Postgres. That all can be a very difficult thing to set up and maintain. With RDS, it's kind of a point-and-click configuration. And the last time I actually had this failover happen, from the time it failed to the time it was actually operational again, the total time was 11 seconds. So it was very robust, and I was very impressed about this particular feature of RDS. A replacement comes online, and then replication simply just reverts back in the other direction. So if we lose an application or a web server, it's even easier because these are stateless boxes. It automatically kills it. The autoscaling group recognizes the fact that it's only got 3 servers online when it's requested to have 4, so it'll create a replacement after it stops routing traffic to it. Comes back online, it stabilizes, it does a few smoke tests to make sure that the code deployed properly, and then it begins resuming routing to that box. And again, you can cut the time how long this happens down to even a few minutes if you design this process properly. So let's say we're yesterday's news. We no longer to be paying for these resources since we've just had a dip in traffic. So we're going to begin the scale down process. Everything just kind of shrinks down automatically, and hence we're paying for what we started with again. So I'm going to show you kind of a network diagram of what I just kind of walked you through here. This is our Elastic Load Balancer in front of our multi-AZ application group, in front of our multi-AZ RD instances. And this is one environment. This is our production environment. Now we can kind of scale that out a bit, and this is what we call our reference diagram at Right Brain Networks. And it's the exact same thing going across the stack, except we're just running it in a single AZ, kind of save on budget. So what we actually have in this particular instance, we've got a test environment, a demo environment, staging, and then production. Now this varies depending on customer requirements, but they all generally look similar to this. And wrapped around all these environments is a single VPC, or virtual private cloud. And since we're inside of VPC, we obviously need an ability to kind of get outside the VPC. So we have a couple of DMZ subnets defined with a couple of load balanced NAT boxes as well, HA NAT boxes. And this is slightly out of date. We've kind of moved to using some of the new NAT gateways that were just introduced about a month ago. And also in this diagram, you're seeing a little bit of out-of-band monitoring and management on the left side of that. We've started to get away from doing that as well. We're putting everything within AWS itself, including kind of the deployment and config management. We do a little bit of monitoring outside of AWS, but the vast majority of everything we have is actually contained within the VPC. So this all works great. But every time I present this diagram, kind of walk through this is the reaction I get from most people. It can be a bit bewildering, especially if you're kind of coming into this new, and you're not used to kind of thinking infrastructure as code and kind of high availability in the cloud. Also, it's not exactly a cheap solution. Granted, this is going to be a lot more cost effective than trying to do this level of automation and high availability in a physical data center, but it's still not inexpensive. That diagram that I just showed you, depending on some of your configuration options, that could be anywhere from $1,000 to about $3,500 a month in AWS fees just to get started on kind of a scalable multi-environment deployment like that, which is not exactly chump change. However, this is the price of retrofitting an existing application to the cloud. It's a very valid strategy. I mean, this is what we do day in and day out. Companies are still seeing a tremendous amount of value in kind of lifting and shifting these applications into AWS. But what if there's a better way to do it? If I'm creating a brand new application from scratch, do I still want to kind of carry some of this legacy baggage of how I'm building and deploying code in the cloud? Or what if I could just use a cloud native way of doing it? So that's kind of where we're kind of moving on here. Werner Vogels said, I think it was reInvent last year, perhaps even the year before then, no server is better than no server. So it's kind of a profound statement. If I'm coming from an IT operations background, my entire job has been to kind of maintain servers. What if I could do my job more effective if I didn't have servers to manage? So AWS solutions to that, in creating serverless architecture, is with AWS Lambda and API Gateway. Now these all pretty new technologies. So if this is something you're unfamiliar with, don't feel that you're behind the curve a whole lot. Lambda itself, it's only been around for a little over, I think, 14 months. API Gateway was released less than a year ago, in fact a little over 6 months ago at the New York Summit in July. And Python support, which is, in my opinion, where Lambda's really started to accelerate, is only a few months old. So this is all very current, very relevant, cutting edge technology. So let's first talk about Lambda here. So Lambda is an ability to kind of run discrete functions in the cloud in reaction to events. It's a little bit difficult to explain. I'll actually get a little demo here. I'll show you a little bit further, but you can think of it as just taking a particular function, and I mean that literally from a programmer perspective. It's a function call that you'd place in the cloud in a single file, and it runs in reaction to an event. An event could be somebody hitting your website. It could be somebody uploading an object to an S3 bucket. It could be receiving an SNS notification. It's just something happens which causes additional execution to be run on this Lambda function. So when it released, it was actually a Node.js implementation. Shortly thereafter, they actually came out with Java. And as I mentioned, kind of more recently, that they've got Python 2.6 or 2.7 support. But the most interesting thing about that is just how stupidly, utterly cheap it is. And the reason being is, let's kind of rewind to the whole EC2 world. If you take an EC2 instance and you launch it for, let's say, half an hour, you're still paying for an hour's worth of execution time. If you have an EC2 instance that's launched and running for an hour and 5 minutes, you're paying for 2 hours of execution time. You're basically paying for provision capacity. With AWS Lambda, you're only paying for the time that your code itself executes. So if your function only takes 300 milliseconds, a third of a second to execute, you're only going to be charged 300 milliseconds of compute time. So you're only paying for actual CPU compute time, which is a radically different way of actually billing for compute capacity. So API gateway. So when Lambda first launched, I mentioned it runs and responds to events, and you were really limited to the events that actually occur within the AWS environment itself. The example that I previously gave was somebody puts an object into your S3 bucket. API Gateway was a pretty interesting introduction because it now allows you to actually assign an HTTP endpoint to your particular Lambda function. So now anything that can call an HTTP request or perform an HTTP request can actually compel a Lambda function to execute. So this is really what allows you to create microservices now with Lambda, which we'll get into a bit here in my demo. And of course, it kind of performs a lot of the same functions you would expect from an API gateway, such as rate limiting, throttling, security, that type of stuff. And it's also as cheap, if not cheaper, than Lambda as well. And again, I'll kind of delve in a little bit further. So before I go too much further than that, I was just wondering if anybody kind of had some questions. It's kind of the traditional way of doing scalable applications on AWS, and kind of maybe some introductory questions to exactly what Lambda or API Gateway is. All right, kind of keep on rolling along then. So describe my business problem here. Is Right Brain Networks open right now? So a very, very simple question, lends itself well to the whole concept of microservices. Have one piece of code that does one thing well. So why do I need to know that? Well, at our core, Right Brain is a service organization. A lot of the activities that occur here are also kind of event-based. Whether somebody opens a service ticket, gives us a phone call, something happening on our calendar, or we're receiving a chat from our website. A lot of these decisions are based upon whether it's business hours or not. So we need kind of a comprehensive way to determine that. So possible solutions, kind of the way that we've been traditionally doing it, is manually maintain that. We'd program into the phone system when we're here and when we're not here. We'd go into our ticketing system and kind of configure that as well. We kind of put a piecemeal solution together. Another option is kind of write some custom logic into each system. We use Asterisk here for a phone system, so the way that I program a dial plan is going to be different than how I might actually kind of configure my ticketing system to respond. So I can still write some logic in it, but it's very disparate and kind of different how I do each one. So then I'm thinking, well, the traditional object-oriented programming approach. I'll simply write a library and have all our systems call that one central library, which would be great if all our systems ran the same programming language, which they don't. So kind of, unless I wanted to get really creative with kind of trying to write C modules that can be consumed by everything, which is just drastically overkill, this is probably not a good option as well. So this is an exact perfectly use case for a microservice. All I need is a single HTTP endpoint. I call it, and it just returns a JSON object. All it is just true or false. Is Right Brain open? So I'm going to show you how to very quickly we're going to do that. Okay, so this is let's find my mouse here. So this is the console, the Lambda console, actually on AWS here. So we're actually just gonna walk through the wizard here, make life a bit easier. We're gonna filter the languages here by Python, and there's actually a microservices example that we're gonna just base it on. Okay, so we're gonna name it. RBN biz hours. It's the name of our function. We're going to leave everything else pretty much the same here. And mouse. Okay, where'd my mouse go? It's on the screen. There we are. So, and as you can see, we can actually write our code right here. Surprisingly, this is actually a pretty effective IDE. If you're writing in Python, it'll actually get your white space all good for you. It's not a simple text box. So it's actually pretty slick that way. Let's see here. Let's go ahead and pop in the code that I actually use, though, rather than kind of the skeleton. All right. Give me just one moment. Okay. Apologize for the slight delay here. Okay, here we are. So I'm going to highlight everything. I'm going to pop in my code here. And so we can kind of create that a little bit here. So this is a pretty simple Lambda function. I'm importing a library called holidays, date, time, some of the time zone stuff for handling conversions there. Then I define which days were open, actually which ones were closed, and I omit Martin Luther King and Columbus Day. We're also closed the day after Thanksgiving. And then I'm basically looking, the time of day and looking for weekends. Pretty simple stuff. And then I simply return a JSON object equal to the value of that function, which is a true or false boolean. So down here, the handler, we're gonna leave that the same. That's a default, which is basically the entry point into that function, and then the role here. So the role, all I need is basic execution role, and this is rather important if you're actually creating a Lambda function that interacts with other parts of AWS. For example, it acts as an SNS topic or an SQS queue. In that case, you're going to want to have to create a role, much like an EC2 role, that actually has permissions to interact with those resources. Since I'm not doing anything, I'm simply returning, a response to my HTTP GET. I'm just going to use a basic execution role. And it's going to kind of walk me through kind of the creation of this. Get rid of Ghostery there. So it created a brand new execution role. And in Lambda, there's basically only two knobs that you have for controlling the performance and the cost. One is the provisioned amount of RAM that you have. The minimal being 128 megs of memory, and the maximum being about 1.5 gigs here. Since I've already tested this function, I know that it can definitely run in less than 128 megs of memory. So we're going to kind of dial that down. And kind of the other kind of knob that you have is how long will that actually execute for. And the maximum that you can actually execute a function for is 5 minutes. So, for example, if I had some sort of logic error that causes this thing to kind of run for indefinitely, this is going to terminate it after 5 minutes. This also means since you can only run for 5 minutes, you're not going to be doing any kind of massive batch processing. You're not going to be replacing EMR or anything like that actually using Lambda. So in my opinion, if you're trying to do something in Lambda that takes 5 minutes to execute in here, you're probably doing something wrong. Lambda performs much better as kind of a piece of glue that ties together kind of larger orchestration pieces. So my timeout, since this is not making any call to any external resources, is we'll go ahead and just set that at say 15 seconds. All right, something like that. My zoom level is a bit high here, 25 seconds. Okay, and this is a pretty new feature. In fact, this was released only last week, is that you can now run Lambda functions inside of a VPC. I don't necessarily need this right now, but if I actually had resources within my VPC that I wanted to access, that's a pretty slick feature. So next, I'm going to create it. And it's automatically going to configure the API gateway here for us using the deployment stage, and we're only doing a get. We don't have to do any post or put. And next, and create function. Boom, that's all there is to it. created our function, created our API gateway endpoint, and this is the API endpoint that I use for calling that. So we're going to open that in a new tab. And I'm going to use this to demonstrate something. Missing authentication token. All right. So I was expecting a slightly different error. I imagine that's our... Oh, I know what I did wrong. So what I did wrong is that by default, when you're creating an API gateway, it actually it isn't going to allow you kind of wide open access. And I kind of skipped over that portion in the wizard here. I should have said it allowed it wide open, and then I would have clicked on it, and it would have actually shown exactly what I said there. Now, actually, it would have created a different error, which I was trying to provoke. It would have given you this kind of cryptic error about unable to do certain find a bit of code, but it wouldn't exactly tell you what the problem was. And what that issue was is if you're actually if you're using basically Python code using the standard library, you feel free to actually edit it in that CLI. Works well. What I actually did though that would have tripped that up is I imported that holidays module, and since holidays module is not part of the standard library, it would have given me an error message, which was different than this one. So how you would have normally gotten taken care of that is when you're using something from the external library. What you've actually got to do is you create a zip file containing both your custom code and the library files, and then you actually upload it via the CLI here. So I actually wrote a batch file to do that for me. And basically the name of my function is RBN business hours, and I'm using my personal account. So basically what it does is it just takes everything in that particular working directory, would normally upload it. And of course it gives me another error here, but that's how it would normally work. And then you would upload it and it would function just fine. So we're going to kind of skip over that though. You're going to have to trust me that it works. The joys of doing something live. But all right, so I'm going to skip through this again. So presuming it works correctly, I'm going to tell you kind of what are some of the advantages of using Lambda and API Gateway are. Okay, API Gateway costs $3.50 per million requests. That's per million request. And data transfer is your standard, 9 cents per gigabyte. Lambda, the first million requests are free. And this is not just like if you've got the free tier at AWS, even if you have an existing account, your first million requests are free every month. And it's only 20 cents per million after that. Now, the first 400,000 gigabyte seconds of compute time per month are also free. And so I mentioned you got two knobs to turn. You've got basically kind of the maximum provision memory and the maximum execute time. So kind of if you combine those two together, kind of what you get is gigabyte seconds of compute time. So depending on kind of how you adjust those knobs, that's actually how it's billed. So total monthly cost, if I actually do an HTTP GET to my API call, it generates a 383 byte response. Since it's a pretty simple execution, it only requires 128 megs of RAM, and it generally executes in less than 30 milliseconds. So I'm actually going with a minimal of 100 milliseconds of execute time. So the total cost for doing that is $3.74 per million queries after I've gone over the free tier of about basically a million. So that's $3.74 per million queries. To do something equivalently in AWS in an HA autoscaling environment, it's going to be an order of magnitude or two. Just to kind of get started doing that. So, a cloud native based application, based microservices, it has the potential to save some serious cache. So some of the gotchas, other than what I experienced here during my demo, I kind of walk you through a few kind of things that I personally didn't encounter in the docs that might save you some time. First off, if you're actually adjusting anything in the API gateway, any change that you make, you actually have to push that blue button that says Deploy API. There's actually somewhat humorous, or at least humorous to me, thread in the AWS support forums where I'm basically just talking to myself for probably about 3 hours. I'm frustrated that I didn't know why any of my changes weren't happening. It's simply because I wasn't hitting this button. I may be the only person on the planet that's encountered this, but if not, at least I'm going to share some of my pain. Other gotchas is that Lambda actually executes within a container that's provisioned with a set version of Bodo, the library for Python. When I was actually playing around with this, there was an occurrence where I needed a newer version of Bodo that was actually included on that particular image. So the way you actually do that is you can package it up just like any third-party library, and you kind of integrate this bit of code telling Lambda to use that function in your own code rather than defaulting to the system library version. Another thing is when you're actually doing a lot of debugging and testing, CloudWatch logs is actually logging all your executes and your debugs and your dumps. And by default, it's set to kind of never expire. I mean, it's like dirt cheap, so it's almost no reason to do it for money-wise cleaning it up. But I noticed when I was doing a lot of experiments, it was really getting gummed up with a whole lot of logs, and it was kind of difficult to sort through those. So yeah, I would recommend that you actually change the expiration to be something a little bit more sane. So some of the other gotchas here, I already mentioned kind of max execute being 5 minutes. Though I don't see that as being a huge downside as long as you're kind of using Lambda appropriately. It's a relatively new service, so there's really no SLAs kind of baked around it. There's no Python 3 support, and kind of the general theme of these is, I mean, this is such a brand new technology. There isn't a whole lot of best practices built around it. When you've got 36 developers all developing microservices using Lambda, how do you coordinate that? How do you do deployments? How do you do testing? Also, when you're doing performance at scale, I mean, it runs on AWS, and at this point, I'm kind of trusting the fact that Lambda could scale to 1 billion concurrent requests, if I needed it to. But I haven't tested it, and I really haven't had the opportunity to test it. So there's going to be some bumps and bruises along the road if you're interested in kind of taking the first step and kind of being part of the initial group of developers who are kind of getting on board and learning all this stuff. I mean, it's a very exciting technology, but like being an early adopter of anything, you have to have a bit of patience. So. We're kind of undergoing our own first microservices internal project at Right Brain. We're kind of eating our own dog food. We're going to attempt to answer some of these questions so we can take the lessons that we've learned and kind of hopefully share them with some of our clients. And perhaps you'll see me back here in 6 months kind of explaining some of the lessons I've learned along the way as well. So that's about really the end of my presentation. I know we had some questions up on Twitter. We also have a question here. Yes? Yeah, so that's a pretty common question, and it's one of the challenges that I've kind of elucidated here. How do you use shared libraries amongst different functions? I've gotten that question a lot. There is a way that you can actually kind of do that by, I'm going to say tricking Lambda, because I mentioned these are all kind of containers. They're essentially Docker containers underneath it. You can kind of burn your own custom AMI and kind of upload it with your own library. I think that's, I don't know whether that's supported or not. It doesn't sound like a very elegant way of doing things. I would think, if you're writing microservices, they're probably going to have their own self-contained library. And if it needs to reach across to another particular function, it probably should use its own microservice architecture, but should probably do an HTTP call out to itself. Now, I mean, obviously, it's going to have some impact on performance. That kind of goes back to kind of being uncertain of how this actually is going to function at scale. And a lot of these complex questions, I don't yet have answers for, but I'm hoping to actually get answers as we get a little bit more familiar with it. But thank you. Yes, sir. Anything out on Twitter sphere there?
Yeah, there's one on Twitter, actually. Do you know if Lambda functions can pass variables to each other?
If Lambda functions can pass variables to each other. Trying to figure out how and what context would you want to do that. I mean, you would simply call another function and use that as an input parameter to that particular function, just like I think you would in any type of normal application. Because each Lambda function is running in its own discrete container. There isn't going to be a way to, I think, reliably kind of access the file system between the two of them. And you certainly aren't going to have anything like shared memory access. So everything's going to have to be done through the interface provided via Lambda. Mm-hmm. Mm-hmm.
Can Lambda functions call each other directly? So like executing another one, just call.
Can Lambda files or Lambda functions execute each other directly? I mean, to kind of like chain together execution. It's a good question. I mean, by putting API gateway between the two of them, so one Lambda doing like basically a curl call to another one, that one I'd be very surprised if you couldn't do that one. Now to actually be able to call Lambda without kind of an intermediate API gateway, that's a good question. I honestly don't know the answer to that. Yes, sir, Mike.
Have you heard of any problems with people using Lambda or any complaints about SLA or anything along those lines?
No, have I heard any problems about people using, using Lambda? I mean, the only complaint that I've really ever heard are people that are using the Java based one, because every call basically spins up the JVM, so you're going to have that bit of latency between the two of them. But I'm not a Java guy, so your questions don't concern me, thankfully. But yeah, I mean, for Java developers, that is a relevant topic. That it would, I think, merit more exploration. Yeah, thank you. Jason, you had a question?
Sure. I think you kind of partially answered it right there, but with the release of Python support for Lambda functions, it seems like the trend is to have Lambda be more programming language agnostic. I was wondering if you encountered any significant differences in performance between different programming languages. You just mentioned that Java is one of them, but any other significant differences you can think of?
Yeah, I barely know how to spell Java. I'm an okay JavaScript guy, though I pretend not to know it just to avoid the pain. I'm pretty decent with Python, so like 90% of my experience working with Lambda is going to be Python. Before they introduced Python support, I did play around with JavaScript a little bit, and actually wrote a function that we use at RightBrain today, or basically any kind of cloud trail activity that occurs. So basically in AWS, if you perform an API call, to modify a security group, launch an EC2 instance, that information is logged in CloudTrail. And we've got a Lambda function written in JavaScript that basically checks those logs. It runs in response to a text file being posted to an S3 bucket. And it ingests that logs files and looks through interesting events. So for example, it might look for somebody changing a security group. In that case, it'll actually open up a ticket in our ticketing system and alert our operations team, hey, somebody changed the security group, don't know if this is an issue or not, but something you might want to look at. It's not running on a huge amount of load, but that one's been pretty performant. That's been awesome. I haven't really created any like heavy-duty real-time and interactive type applications yet, and that continues to kind of be somewhat of an unknown. The first problem that I'm trying to solve is kind of isn't so much performance related of the application, but performance of developers. I can see a lot of potential problems when people are trying to collaborate. To Ian's question about how do you actually share library functions and stuff like that. I think that's the performance problem that I need to solve first, and then kind of the at scale of actual execution time is going to be something further down the road once I figured out the harder stuff. Yep. Yes, Mike, question.
Yeah, so my company was thinking of using Lambda for an upcoming project, but security guys pretty much shot it down. Something about RDS and it has to be a public endpoint or something like that. But when you mentioned this VPC now, is that possibly a solution to this?
Sure. So I'll kind of rephrase the question in the fact that I earlier mentioned that they just introduced the VPC support in Lambda, and kind of what's the relevance of that to me or to my security operations folks. So VPC is an ability to kind of quarantine off a portion of the AWS cloud and give you much more granular control over that. You get to control the security group, network ACLs. You get your own private IP addresses that you're going to assign. And the incorporation of a Lambda into that allows these Lambda functions to actually work within the confines of your VPC. So it allows you to kind of use Lambda without having to worry about possibly somebody on the public side of your cloud actually accessing it. And at RightBrain, we found a huge value in Lambda for things that we would traditionally use cron jobs for, because now it can actually run in response to kind of a cron schedule. Kind of these maintenance or monitoring type jobs. So the fact that we can actually now use that in kind of the security context of AWS within the VPC has been a big help. Yes.
So as Lambdas and API gateways are code, we would presumably keep them and the libraries they import inside of some kind of repository for versioning purposes. Is there an automated way of replacing these libraries and I guess this code on merge? Or is there some API for those of us who use custom deployment solutions?
It kind of goes back to the complexities of deployment and kind of orchestration of your code. I'm basically writing hello world applications here yet, so the fact that you're even thinking about that, I think puts you a couple steps ahead of me on that one. So, all right, appreciate it. Thanks for coming out here, and I hope this has been helpful, and best of luck in your microservices journey. Thank you.